Next, we have Surabhit, who is a PhD student in mechanical engineering. Surabhit, if you want to start to share your screen.
So good evening, everyone. I am Surabhit, and today I'm going to give you a tour of what our lab is doing to enhance the manufacturability of composites and make it more accessible to everyday people. So composite materials are materials that are made out of two or more submaterials, and they kind of take the best of both worlds. A part made out of a composite material would be almost as stiff as the metal part, but it would be a fraction of the weight, and it behaves a lot better under stress, and is a lot more formable and is less susceptible to fatigue-related failures like creep, and it is a lot stiffer for the same weight. So these are the things why we should be looking at composites. But there's a reason if you look around you, you will not find a single composite material. And that's because it is extremely expensive and energy intensive to produce. And we could be saving a lot of weight and complexity by using composites, but we do not because we do not have effective welding and joining techniques to make assemblies out of composite materials. So we can make a monoblock chair out of a composite material, but something like an office chair which has adjustable armrest or wheels that cannot be made out of composites as of now. And there's a reason for that. Until a few decades ago, the only way we had at our disposal to manufacture composites was an autoclave that you can see on the right-hand side. And an autoclave is something that manufacturing should not be. It is large, it is expensive, it takes up a lot of floor space, it is extremely energy intensive, it is a fire and safety hazard because of all the temperatures and pressures that are involved. It requires a lot of skilled personnel to operate, and it is extremely sensitive to the processing parameters. But engineers kept trying and started unlocking newer forms of curing composites. The first one we had was resistive heating. Then we went on for inductive heating. Then came ultrasound heating. Finally, we had cooler, more novel forms of heating like microwave, laser, and the one that I am most excited about, radio frequency. So radio frequency is pretty much like alchemy. If you blink your eyes or look away for a moment, you will miss the transformation. On the right hand side, you can see we are heating up a strip that heats up so fast, it pretty much looks like a stormtrooper has flipped the switch of his lightsaber. So in our lab, we have already used radio frequency to heat stuff, to weld it together, to make chemicals react, to heal a broken material, to cure composites, and to bond dissimilar materials. And when we take all of this together, these are the building blocks of additive manufacturing. So here is a schematic representation of what we can do with radio frequency. On the left-hand side, you can see flash. So that means we can process stuff so fast, it would appear that a flash is working on your factory floor. We can heat stuff so fast that air can spontaneously light up on fire, like on the top right-hand side. We can target energy so precisely it would look like Superman used his laser vision. And we can morph and change the properties of materials like that ghost on the bottom right. So at this point, when I tell you that a wing of an aircraft or a sports car has been made out of a composite material, it doesn't really surprise you because composites are already the present standard for low volume and high margin industries. So, but we would like to see it become more prevalent in our everyday lives, and that is only possible when we automate the process and to make it more suitable for an assembly line where it can be mass manufactured. So here is what we want to do. We want to take composites from an artisan's industry on the left-hand side, reserved for the few aristocrats, to something that is more democratized and can be purchased by everyday people, and can be used as a general purpose technology where it can be used for more than one industry. So I'd like to leave you with this thought. We would like to see this technology become material agnostic and input agnostic to a point where it is completely automated. So I would like to leave you with this article, which argues that throughout our history, we have often wondered what is it that makes humans different from other species. So sometimes we have come up with a lot of answers. Maybe it is tools or culture or our social organization. But every time we come up with a new hypothesis, we find a rudimentary version of it in some animal species. But this time we believe we have the answer. Humans are the only species that can automate stuff. automation is different from tool use in the sense that tool use reduces your physical load and automation reduces your cognitive load. With that, here is our group. We are a lab that works on robotics, manufacturing, and materials. And when we can put these together, we can create more automated, more efficient, and more sustainable industries for the nation and better performing products for the market. With that, I'll thank you very much for your patience.